More quadratics, okay? What kind of quadratics? We did factoring last time, but we just factored expressions. Did we solve quadratics yesterday? No, okay? We just factored them, right? And they weren't all this, as we saw number 4 and 5, they weren't all quadratics anyway, okay? So all we're going to do today is work on quadratics. So let's talk about the different ways to work on a quadratic. What's our first one that we already learned? Factoring, right? And as we saw in number 27 of the homework, it was not factorable. So how do I solve something that's not factorable? Okay, I could complete the square on that sucker, but I don't want to. And the reason why, if I believe it was 9x squared minus 7x plus or minus 56 or something like that. I can't remember exactly what it was. It was plus 7x. Oh, there was even a plus there. Yeah, I thought it was a minus. Anyway, similar, right? And that guy didn't factor. So how would I solve him? I can complete the square on him, but no, not whatsoever. Okay, I know how to do it, and I still wouldn't do it. Okay, that's not. If this guy isn't 1, I am not doing it by completing the square. Second, last way is, raise your hand, I guess you know. You could solve for x. How do I solve for x? That's my goal. Go ahead. Quadratic formula. Yeah? If you guys remember what quadratic formula is, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Awesome, but guess what? Every single one here, I'm going to use this. Okay, now don't just mouth it. I can tell if your voice is coming out. Okay, so we're all ready? Hit. I don't even know how that works. And they do that. I'm like, what does that even do? I'm just telling you guys when it comes to music, fail to record a 4th grade. If my daughter's in viola, I'm like, are you sure you want to do it? Yeah, I'm like, it's like, yeah, there's like chords and some like the chord. I don't know. Okay, so we're gonna sing it. Ready, go, here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. It needs more goose for me. No, I'm not that. You guys just thank you. Now, some teachers might have taught you opposite b instead of negative b, which is the same thing. What does opposite mean, by the way? Yeah, because if I say what's the opposite of 8, it's negative 8. What's the opposite of negative 8? It's opposite. Makes sense to everybody? Okay. Those are the options. We have factoring, completing the square, which that's the one that most people don't use as often. I prefer never to use it if I don't have to. Sometimes it's actually a little bit easier than doing the fundamental formula. And sometimes I prefer to always factor if I can. If I can factor, that's the way I'm going to go. Because I'm quicker at factoring. Does that make sense to everybody? Today, you're going to actually have a choice. You're going to have some of your homework that says, choose which way you're going to solve this quadratic. You can do any of this. Second way, they're going to tell you you have to complete the square. And then they're going to tell you the quadratic formula, and some are going to tell you the factor. Okay, does that make sense? So I'm going to start off with completing the square. But first, we got to understand the pattern of completing the square. All right, for these 3 rows over here, that's Thomas's row. Oh, help me name again. Brady's row, and Alicia, I want to say. Was I right? Yeah! Okay, you guys start working those out. See what that is as a quadratic expression. You 3 are going to be going here. You 3 rows. Okay, oh, Cosette, got that. Hadley, because that's Hadley. I know Hadley already. No offense, I'll get to know you too. And my man Daniel was in driver's ed. So you guys get these 3 to go. Now, Just a quick reminder, is this x squared plus 9? A lot of people want to just, oh, I could just bring him in. Please don't. Okay, what do we have to do? Remember, we have to do it as x minus 3 times x minus 3, and then we can distribute. Okay? I'm going to push pause for a minute, and you guys ready to finish those out. X minus 3, Goldine. X minus 3, what was your answer? Good. Miss Flowery Dress Lady. What's your name? Nicole. Can you tell me what x plus 5 squared is? Plus what? Good. Okay. Right here, help me again, though. Kaylin? The bottom one? Okay. Coming over here. Let's go into dark. First name now. Jaden, go ahead and tell me what this one is. Thank you. Okay. What with you?
I got x squared minus 18x.
Income, tell me the table. And then last but not least, let's go behind McHenry. Right there, yep. Right here, Richard. Yep. She has Richard. Uh-huh. There you go. Okay. Can we see a pattern that I wouldn't have to distribute through every time I see a binomial square? Is there a pattern that I can do a binomial square without having to factor? James, you're shaking your head. Can you explain it to me? Yep, so this guy right here, we multiply by 2, and then we square. Multiply by 2, and square. Thank you. Okay, every time, that is hopefully the pattern that you see. And really, to be honest, it's square him, right? Multiply these two together, then times it by 2. And then square. Right. Do you guys see that pattern as we went through? If you didn't see it, quickly look. Just remember as a minus 4, so negative 4 squared is negative 8. Negative 4 times itself is 16. X squared, negative 9x doubled, 18x plus 81, right? Once again, sometimes I teach you guys like you haven't ever seen this before, but you guys have all seen completing the square, so just so remembering why, okay? So now, my question to you is, how would I do this? Okay, go ahead, Curly. Close. 2bx, right? Because I got a double. Right? Does that make sense to everybody? Okay, what about this? What is he as a binomial square? Sabrina, right? X minus 7, because what did you do? You cut him in half and said, what's the number that we're cutting this guy? Because remember, we double, so therefore if we want to find the number, we've got to cut it in half, right? Right? And then what is this number, just to make sure? Cut him in half, and then square him just to make sure it works. Good? Okay. So, what fills the blank? What is 13 squared? So once again, we cut him in half, right? Cut him in half. Half of 26 is negative 13. Negative 13 squared is 169.
So that fills the blank, right? And then, correct, what would this be as my binomial squared? There it is. So if I can go to here, then I can make him into a binomial squared, which actually makes it easier to solve. Okay? Is everybody with me on that? By the way, I'm going to show you guys quickly, how did the quadratic formula come about? It came through containing the square. And I'm going to show you really quickly. And if you've seen it, awesome. I'm just going to prove it to you that this is why. Now, do I ever expect you guys to do this? No. But sometimes we want to know why. You guys want to know why sometimes. I'm going to show you why. Where did that come on? How do we know that every quadratic equation can be done by the quadratic formula? Because every quadratic equation can be solved by completing the square. Every single one. Now, do I always want to? No. But it can be done. Now, me personally, I always like my complete square is my leading coefficient to be 1. Is it? No, it's a. So guess what I'm going to do? I'm going to divide everything by a. So I get x squared plus b over ax plus c over a equals 0. Yes? No? Maybe so. Okay. Is this a perfect square trinomial? If I cut him in half and square it, is that what this is? No, right? So I'm going to get him to the other side. And once again, you guys don't even have to write this down. Just kind of check it out to understand what it is. Right? Now, you see how I have that blank? Just like I did before, I'm going to fill the blank. How do I fill the blank to make it a perfect square trinomial? Remember, we took this number and we cut it in half. Okay, what's half of b over 2? b over 2a. But then I take that number and I square him, don't I? Right? If you recall from the previous example, or was it up above, remember I cut him in half and I squared him to get to this number, correct? So, no, what the heck is that? I don't want you. Go away. Let's play with it anyway. Oh, that's fun. I like that. Oh, dang. Stop it. How do you get rid of them? Anybody know? Control Z that thing. That's a, yeah. Go away. No. Anyway. All right, it's okay. We'll just go along, sing our own song. It was x squared plus b over ax equals negative c over a, right? Okay, so we're going to cut him in half. That's b over 2a. Square him. B squared over 4a squared, because the bottom was 2a, so 2a times 2a is 4a squared. Can I all of a sudden just chuck anything up there I want? I like you, Cosette. Okay? That was kind of hard for me to say. Not that I don't like you, but go next door neighbor girl. I don't think I've ever said I like you, Cosette, ever in my life. Until now. Kind of a fun thing. Anyway, so this side, if I add b squared over 4a squared, I got to add b squared over 4a squared. Right? Balance. This is a perfect square trinomial. E is x plus b over 2a. This guy, what do we do when we add fractions? We need a common denominator. So I'm going to times this guy. He needs a 4 and an a. 4ac. B squared minus 4ac. all over 4a squared. How do I get rid of a squared? Square root it. Anytime you take a square root, you got to remember the plus or minus. A lot of people forget the plus or minus. Square root of that stuff is still square root of that stuff. But the bottom becomes what? What's the square root of 4? 2 bottom of a squared. Okay. And this is last but not least, is x by himself yet? We're going to just subtract him over. Because they have a common denominator, hence why the quadratic formula works for every single quadratic equation. Because it comes from the most generic, basic equation in the Okay? Just want to show you, do you have to know that? No, but sometimes people are like, where did these come from? So I wanted to give you an idea of where. All right. Yeah. Tired? I'll leg rest. Did I ever leg wrestle you, Cole? You decide never to try. All right, we good? Curly? Good. All right, so here's the one we're going to solve. Sure. That's the one. We're going to do this by completing the square. Now, I'm going to tell you straight up, guys, I never want you to do completing the square unless the coefficient is 1. If it's not 1, don't do it. Even if it tells you in there, don't do it. Because the reason being is I would never do it. If it, you know what I mean? So it's like, unless I'm doing maybe putting equations into a circular or an ellipse or a hyperbola type thing, I wouldn't complete the square unless it's coefficient. Yes. Dan?
So I have a question with like the so what if you have a question like x squared like minus 14x plus 49?
Mm-hmm. That's a perfect square trinomial.
Yeah, but how do you know whether it's x plus 7 squared or x minus 7 squared?
Okay, well that's the difference between the plus or minus. And what's the half of this number? Negative 6. That's going to be what.
Okay.
Any question?
Yeah.
Is this a perfect square trinomial? Why? What needs to be there? What's not perfect to make it a perfect square? I need that 21 to be a 36. Okay, because I cut the middle number in half, right? Cut him in half and square him. Half of negative 12 is negative 6. Negative 6 squared is 36. That's not 36. I guarantee it. Okay? Can I make a 21 into a 36? Just add 15, right? But once again, can I just all be frilly willy over here and just add 15? What I do to one side, I gotta do to the other, right? Now, some people would prefer just to do this. Now, I'm gonna just show you 2 ways really quick. This right here now becomes x minus 6 squared, because that is 36, right? Now it's a perfect square trinomial. If it's a perfect square trinomial, I can go into a binomial squared. That's the whole goal, right, of completing the square, is to make it a perfect square trinomial to go to the binomial square, right? What's this side? And I can keep going. Some people also like to do this. I subtracted the 21 over because it didn't make it a perfect square trinomial. What fits the blank? 36, right? Then I add 36 on here. What's negative 15 plus 36? 15. It still gives me my. So whatever you so choose, if you want to get that guy over to the other side first and then just fill the blank, and make sure you fill the blank on both sides, that works just as well, right? Is everybody with me on that? Understanding how it's the same idea, it's just two different ways? Okay? All right, so here's where we're at. How do I solve? How do I get rid of a square? Square root. Key thing there, though, anytime I take a square root, plus or minus, which a lot of people forget, so try to get that in your head. Before I do the last step, can I break him down? Can I break down square root of 15? What's in there? 5 and 3. Are they buddies? Remember, square roots like buddies, like 4 is 2 and 2. They're buddies, right? Wow. Go ahead, Miss Merkley again. One get shot. Something like that. Did she say that? You gotta have 2 people to get out of jail and one get shot. That's what I'm always have to do it. Okay. Then we're not done. What do we do? Add the 6. Once again, guys, 12, 10, 12, 10. It is 6? Okay. Thank you for saying. There we go. You are messed the heck up.
I was like, how attractive is that?
Yeah, I know that's okay, going on. Here we go. We're going to do it. Yes, yes.
Yeah, I would do it
I wouldn't. Kind of how I did it with the A value, right? I divided it by.
So let's say it was 3x squared minus 12x plus 21. I divided it. And then you just go with it. Then it might be that you have a fraction you got to cut in half.
Does that make sense? Okay, we're not going to do it via complete square. This time we're going to do it via, because we can't do a factoring, right? How do we know it didn't factor? You guys know just from our previous answer. A, not plus or minus. Do you guys see how it was not a, first off, you guys remember what rational numbers are? Things that can be written as fractions, right? Whole numbers on top and bottom, or integers on top and bottom. Okay, if they come out to be rational answers, you knew you could have. Okay, but this can't factor. And first off, factors of 21, they give me a 12. There's nothing that does that. Okay. So, what if we didn't want to complete the square? We're going to do the quadratic formula. So once again, who is my A value? 1. You guys are the first class that said 1. Guess what everybody else has said? 0, x squared. Remember, the A value is the number in front of the x squared, right? Okay, who's my B value? And my C value? The bathroom? Right. Don't like Russell? That's what I'm saying. Oh, no. That's an Indian leg wrestle? I don't do the stick one. I call it the Joseph. Because he used to win in those all the time. He's just he's a nice gentleman. You guys don't know about him? You read about him, but you know about him. Is he really? Learn something new today. Oh, I love it. It's actually, all right, here we go. So we're back on it. We got our A, B's, and C's. Okay? And now we're just going to plug and chug. Because that's all it is. Right? Quadratic equation formula is so easy because it's a plug and chug. Correct? Here we go. X equals negative 12, which is a positive 12, right? Plus or minus square root of b squared, which is 144, minus 4 times 1 times 21, all over 2a, which is 2. I even sing when I put it in. Any questions on where I got those answers? Okay. By the way, what's anything negative squared or any number squared? Positive. So see how I don't work out because sometimes if you put it in your calculator and you do negative 12 squared, what is it? Negative 144. Meaning that it's actually just through our order of operations. X bar first negative. Correct it. Then square it. That's the correct way to do it, right? So sometimes I just want you to be careful using your machine, right? Okay. This guy is 84, just to let you know, right there. 4 times 1 times 21. So then I get 12 plus or minus 144 minus 84 is 60 all over, oops, square root of 60, all over 2. So that's not the same answer I got on the previous question. Why is it not the same yet? Well, I need to simplify. Because like on the last one, square root of 15 did not simplify, but square root of 60 does. What's in 60? So 2 and 30, 2 and 15, and we already know 15 can't, right? But there's a pair, not there. Says you would. X equals 12 plus or minus 2 root 15 all over 2. And then that all have a what in common? 2. So I got 6 plus or minus root 15. Which is the same result, which it should be the same result because it's the same darn freaking. I can make you run here. Let's do it. Hold your stuff. Fall. You don't see it. I want you to do it. There you go. Hold on. Don't fall. Okay. I like to have a recliner. Okay. X squared plus 4. No? You need help? There you go. Thanks for letting me mess around with you. Okay. Can I factor this? Sum of squares. Can I factor a sum of squares? Yes and no. No in real solution. Yes in imaginary. Okay, now the reason being, okay, the reason being that this is imaginary is this step right here. Why does that make it imaginary? Square root of -4. Not necessarily that it's always the square root of 4. Right? -4, but it's not even necessarily the square root. The part that we're saying right there is, can anything squared ever be negative? That's the reason, right? That doesn't make sense. -2 squared is 4. 2 squared is 4. How does something squared ever be negative? Hence, the imaginary part. Now, I really wish they did determine it as real and imaginary, because as soon as we say imaginary, people are like, why don't we do it then? It is applicable. There's still tons of things to use for it. I don't know. This is my real world. Right? Okay? All right. But I hear electricians use it. Supposedly. But I don't know. I never was an electrician. Okay. So, ladies and gentlemen, how do I get rid of square? Square root. Big Thomas, you want to carpool one day? Should, huh? Right. I come in the very early morning, so you'll have to. Aren't you cross country in the morning? Square root of 4 is 2, but anytime I have a negative, and remember it should be plus or minus. Right? Now, last class somebody's like Mr. Roberts. I thought square root of 1, negative 1 is I, not negative 4. Isn't this the same idea? What is the square root of 4? 2, square root of negative 1. Remember multiplication of square root, we can just multiply the numbers as long as they're the same radical. Right? Do you not remember that? Can I times these guys together? No. Now I can make this, right? Or this is the 6th root of 4 and the 6th root of 8. Those are equivalent to these.
Okay, I remember that.
Because what I did there is, how do I need to get him to a 6? I times it by 2, so I got to put a 2 power here. 3 power, 3 power. Does that make sense? And now I do, right? Anyway, doesn't really matter. Okay. All right. Perfect. Want to talk about really quickly. How many solutions? 2. Cross the x-axis. What? Ooh, what the heck is that? I really swear there's a control Z thing on here. No, that just takes me back. No, it used to be like down here. Anyway, oh well. So what about this? Just imagine that touches. Here, we'll put a big dot. There we go. Okay. How many solutions? 1. Now I want to kind of counteract that a little bit. It is one real solution, but have you guys ever heard of multiplicity? Okay, multiplicity means the same number is twice, or same number more than 1. Okay? Because technically, anytime I have a quadratic, how many solutions I'll always have? 2. It's called the fundamental theorem of algebra. Whatever the highest degree is, that's always the amount of zeros that you will have. Now that says I only have 1 0, but that 1 is being white. Let me explain why. Let's say I had this after I did the quadratic formula. Okay, what's the square root of 0? No. 0. 0 times 0 is 0. So we have this, right? Which is 4 plus 0 over 2 and 4 minus 0 over 2. So there's 2 solutions that give us the same result. So technically, yes, there's one real solution. It's always going to sense, but it has what we call a multiplicity of 2. We're going to get the multiplicities a little bit deeper a little later and how they affect our graph, but that's still considered 2 0. Does that make sense? Okay. What about a graph like this? We have no real solutions, but there is
Imaginary.
how many? 2. Once again, still. Does that make sense? So if they ask us how many solutions this is, what are we going to say? 0 real, but 2 imaginary. Make sense? What are we going to say on the blue one? 2 real solutions, and then they might ask you to look on the paper. I can show you on your calculator, but I don't think we are doing that today on this. I would highly suggest you guys get your calculators coming up because it's going to be on the test, but there's some things you're going to have to do. And then this one guy has 1 real solution, but multiplicity of 2. Okay? Yes, no? Yes.
So the one solution that
Nope. Imaginary solutions always come in pairs because of the plus or minus. Can't just have one solution. Always will have a plus or minus. Okay. We're almost there. Okay. We got 2 more examples. Give me any number you want, Mr. Dude sitting behind track right there. Yep. Any number. Blame him. Okay, Karen, give me another number. Alright. Now I get it. What do I have? I'll make it easy. All right, there we go. I don't want to think anymore, so that was an easy one. Okay, we're going to set this equal to 0 and solve by factoring. 7 times 42. If I did it right in my head. 292. 4. Dang it. This is a 3. I just made it a 3. Okay, so we have, what do we have? 294. So notice the factors that give me 293 are 1 and 294. Seven x squared plus x minus 294x. By the way, this is Cameron's fault. Really,
I always think
yeah, is that your number?
not my number. I like
Okay, here we go. What does the front guys have in common? That's going to help us on the next part. They have an x in common. Left with 7x plus 1. What does the back guys have in common? 42. You want to know how I knew that? As well as, because, see how this is a 1? When I factor it out, I better have a 1 there. So what's negative 42 divided by what gives me a 1? 42. Understand, everybody? So I have a negative 42, and that's left with 7x plus 1. So I have x minus 42. I am sweating like no other. Okay, now that's how we factored yesterday, but we didn't solve yesterday, did we? So when we're to the stage of our 2 binomials, how do we get to our solution? Now remember, this says a binomial times a binomial, correct? When I have 2 binomials timesing and they equal 0, one of the binomials has to equal 0, right? So we set both because we don't know when it's going to happen. We want to know when this guy equals 0, and we want to know when this guy equals 0. If he equals 0, is he necessarily 0? No. If he's 0, is he necessarily 0? So we want to have both times. Okay? So as you just said there, though, Curly, we want to set them equal to 0. Because that will tell us, oh, what value makes this 0, right? X is 42, that's a pretty simple one. Now, ladies and gentlemen, I am not a decimal person. Okay, if you put decimals on your test, I will mark you wrong. Okay? If you use mixed numbers, we're not freaking cooking. Okay? We don't use mixed numbers. We use improper fractions or reduced fractions. Okay? Unless it starts with a decimal, don't put a decimal because decimals are out the devil. Awesome. I'm not simple. So, and the reason why, guys, can I use decimals? Sure. The reason why I really don't know is on your ACT is they reduce fractions a lot. If you don't ever reduce your fractions, you know how to use those. You only use your calculator to figure it out. You want to react. It's easier to always take a fraction and turn it into a decimal than always knowing how to use decimals and not know how to use fractions. Does that make sense for me? So for me, it's more end of year or big test. That's the reason why. Does that make sense? Any questions here? Last example. The last thing I'm going to give you is a solution. X is 3, X is -3/2. This time, I give you the solution, and I want you to find a possible equation. Now, the reason why I say a possible equation is that there's actually an infinite amount of solutions that have these zeros. If you think about it, let's just imagine this is where I'm crossing at 3, this is where I'm crossing at -3. There's one solution, right? What if I use the same zeros that fit in there? Another possibility, right? What if I make that tighter to go through the same zeros? Right? You see how there could be an infinite amount of zeros? An infinite amount of equations. So I'm only asking for one. But we're going to go through it. So this is kind of like going backwards from the previous problem we just did, right? I gave you the answers. Now I'd like you to go backwards. Okay, and how do we do so? Well, just like on the previous problem, a little bit down here, notice I had these results, and then I made it equal to 0. Right? Okay? So I set these guys equal to 0, or I want them to equal 0, so I subtract him over. Now on here, guys, I'd like you to, anytime you have a fractional answer, let's not just add the 3/2 over. Let's times it by 2. So I'm at 2x equals -3, or 2x plus 3 equals 0. Does that make sense to everyone? Then, put them back into their binomial state. Is that equation quite as where I want? Yes, that's an equation, but it's not quite where I want to go. Just need to distribute through, right? I'll get 2x squared plus 3x minus 6x minus 9. I went this way. And then this is -6. Oh, I will. I haven't got there yet. I see what you're saying now. I get where you're going now. In the end, after I simplify, that's what you're going for. I just didn't get there. I was just showing myself. That is a possible equation. Is it the only equation that goes to 0? I could multiply everything by 2. That gives me another one, doesn't it? I can multiply everything by -1. Gives me the same result. Okay. Everybody there with me? Any questions? Okay.